Okay, here we'll talk about existence theorems, and in the calculus book it's just mean value theorem and Rolle's theorem, but on the AP test they're all put together with the intermediate value theorem. So let's see what we can guarantee based on this information. We know 2 points on a graph of a function, and so must there be an x value between a and b such that the slope of the function is 0. So we're looking for the existence of a horizontal line somewhere between here. So let's look at some of the possibilities. If we have 2 points and the graph goes like this, then we know there must be a horizontal tangent line and a slope of 0. But there could be a graph like this and there's no horizontal tangent line, there's no slope of 0. We could also have a piecewise function that goes like this, and there's no horizontal tangent line. So in order for there to be a horizontal tangent line, the graph can't be non-differentiable. It cannot have a corner in it, and it cannot be discontinuous. So to guarantee a slope of 0, we must have a continuous and smooth graph. And this is for Rolle's theorem. And now we look at mean value theorem. We know this much, these 2 points on a graph, and must there be an x value between 1 and 2 such that the slope is 3. So here's the graph of f. Does it have to have a slope of 3 somewhere between these 2 points? And if we have points like this and it curves and does some other things between the 2 points, here is the secant line, and we know that there has to be there's a tangent line parallel to the secant line. We know that the secant line, the slope is 5 minus 2 and then 2 minus 1. The slope of the secant line is 3, but does there have to be a tangent line with the same slope? And if the graph looks something like this, we can say there's a tangent line there, there's a tangent line there. Both tangent lines are parallel to the secant line, so they have slopes equal to the secant line. If we have something like this, we would say there's no slope of 3 between the 2 points. And we could also have something like this. No slope of 3. The slope of 3 would be right there, but here we have a slope greater than 3, and then we have a negative slope. So we have the same conditions as Rolle's theorem. It has to be continuous and smooth. So if it's continuous and smooth, then in this case we can guarantee there is a slope of 3 guaranteed by the mean value theorem. All right. So let's just have this organization, because with Rolle's theorem we have three conditions. We can think of these as three conditions, and then the implication. So now let's look at the mean value theorem. And here we have just two conditions. If f is continuous, on AB, and f is differentiable or smooth, you can say smooth on AB, then there is C on AB such that f prime of C is the slope of the secant line. So that's f of B minus f of A over B minus A. Here we only have two conditions. And now we're going to go down for the intermediate value theorem. We only have one condition. All right. And this just means on any interval a to b, if f is continuous, then here's f of a and f of b. There must be an x value between a and b such that its y value is between f of a and f of b. So here's f of c. There will be a y value between a and b, just because to get from this point to that point, there's no jump if f is continuous. So it has to connect. That means there has to be a y value. Determine whether Rolle's theorem can be applied. If so, find the C guaranteed by Rolle's theorem. So let's look at the conditions. We need to have continuous, differentiable, and f of 1 is equal to f of 4. So we have three things to check, and we say it is continuous because all polynomials are continuous. It is differentiable because all polynomials are smooth or differentiable. And then we check f of 1. F of 1 is going to be 0, and f of 4 is going to be 0. So this is true. Okay, and then we say what is implied by this. there is C in the interval 1 to 4 such that f prime of C is 0. And then the question says find C, so we'll need to find the derivative, and we'll want to know the value for which the derivative is 0. So we have 2x equals 5, and we have 5 over 2, so we'd say C equals 5/2. Okay, same question, and let's look at f of x equals 3 minus x minus 3 on 0, 6. Does Rolle's theorem apply? If it does, find the C guaranteed by Rolle's theorem. Pause the video and try that one. Conditions. It has to be continuous. The function has to be continuous, differentiable, and f of 0 has to equal f of 6. So we have an absolute value. Let's look at the graph. It got shifted right, up, and reflected. Right 3, up 3, and reflected. So let's think about these conditions. Is it continuous? Yes. Is it differentiable? No, because it's not smooth right there. So we can just say that Rolle's theorem does not apply, and there's no C guaranteed by Rolle's theorem such that f prime of C equals 0. It turns out that is a yes, but there's a no there, so we can't use Rolle's theorem. All right, let's do for f of x equals x cubed. Does the mean value theorem apply? So we look at the conditions for the mean value theorem. The function has to be continuous and differentiable. X cubed is continuous and it is differentiable. All polynomials are smooth and continuous. So the implication is there is C on 0, the interval 0 to 1, such that, let's do parentheses, such that f prime of C equals f of 1 minus f of 0 over 1 minus 0. And then find C. So that's a different part of the question, and we're going to find the derivative, which is 3x squared. So f prime of C will be 3c squared. And then we have f of 1 is 1, f of 0 is 0. positive or negative radical 1/3. This is an x value, but we're only on the interval 0 to 1, so then we will only use the positive. Just keep the positive because we're not looking at negative x values. Okay, f is smooth or differentiable, same thing, and continuous on the real numbers. And, the previous questions were pretty easy and you were directed what to do. But this is more of how the questions appear on the AP test, and these can be some of the hardest questions on the test. So let's practice these. And so you're given a table, and then they ask about the existence of function values and slopes. All right, so let's start by considering, thinking about the levels of rates. And we have f, f prime, f double prime. We have to know where we're starting. So we're given f. So we start on f, and then we have to think about what we're trying to find. We're trying to find f prime. So we have to move down a level. And when we move down a level, we'll be using MVT or Rolle's theorem. And you can use MVT, it's going to work, but Rolle's, there's just less computation with Rolle's, and because it's a 0, we can use Rolle's theorem. So the function is smooth and continuous. Those are the conditions. Let's go ahead and review the conditions for Rolle's theorem. Continuous, smooth, and we're looking at the interval 1 to 2. We have to see that, check if f of 1 is equal to f of 2. F of 1, f of 2. No, so it is continuous, it is smooth, but f of 1 does not equal f of 2. So Rolle's theorem does not apply, and we'd say that there's no c guaranteed on the interval 1 to 2 such that the slope is 0. Okay, is there a c? Let's shorten that. C on negative 1, 2 such that f prime of c equals 0. Okay, pause the video and try that one. So we are still starting on level 0. We're trying to find f prime. If you move down a level, it's MVT or Rolle's. And here we're trying to find a slope of 0, so we use Rolle's theorem just like we did in the previous one. Yes, yes, and all we have to do is check f of negative 1 equals f of 2. Is that true? F of negative 1, f of 2, they both equal 4, so that's true. And then we can say there is c on negative 1, 2 such that f prime of c equals 0 by Rolle's theorem. So we'll just do, say what theorem we're using. Okay, let's do, is there a C on -1, 0 such that f of C equals 0? All right, and we have 0, 1, 2, f prime, f double prime. We're still starting on level 0 because we're given f, but it's asking about f, and we're staying on the same level. If we stay on the same level, we'll use the intermediate value theorem. And the conditions, there's only one condition for the intermediate value theorem. It's continuous, so that was given. Therefore, we can use the intermediate value theorem, and let's check f of -1 and f of 0. F of -1 is 4, f of 0 is -2. To go from 4 to -2, do we have to have a value of 0 between them? Yes, if we start above the x-axis and in below the x-axis, we can say that there is a C on -1, 0 such that f of C equals 0 by intermediate value theorem. And if we state this and we state this, then we can just automatically write that. You can add more sentences if you want, but this is adequate. All right, and then just so that we don't get too comfortable with f and f prime, let's look at f double prime, or f prime. F prime is continuous and smooth for all real numbers. Is there a C such that f prime of C equals 0 on -1 to 0? Pause the video and try that one. All right, we're given f prime, so we're starting on level 1. We're finding level 1. We're ending on level 1, so we need to use the intermediate value theorem. And it has one condition, that the function is continuous, so that was given. And then we just check f prime of -1, f prime of 0. F prime of -1 is 1, f prime of 0 is 2. So, to get from 1 to 2, do we have to cross 0? No. So we say no C guaranteed by IVT such that f prime of C equals 0. Or you can just say no. Okay, pause the video and try that one. We have the same levels of rates as before. We're starting on f prime. We're starting on f prime, and it's asking about f prime, so we need the intermediate value theorem. We know it's continuous, and so now we just check f prime of 0, f prime of 2. F prime of 0 is 2. F prime of 2 is negative 2. To get from 2 to negative 2, we have to cross 0. So we can say that there is a C on 0, 2 such that f prime of C equals 0, and we say by the intermediate value theorem. Is there a C such that f double prime of C equals 0 on negative 1 to 0? Pause the video and try that one. We're given f prime, starting on f prime. We're ending on f double prime. Since we move down a level, it's either going to be mean value theorem or Rolle's theorem. Since we're looking for a slope of 0 or a derivative of 0, we can use Rolle's theorem. So we go through our conditions, and it's continuous. That was given. It's smooth, continuous, smooth. Then we check f prime of negative 1. Is that equal to f prime of 0? On this interval, are the y values of the endpoints equal? So f prime of negative 1 is 1. F prime of 0 is 2. So we have a no on one of the conditions, and we'll say that there is no C guaranteed by Rolle's theorem such that f double prime equals 0. Is there a C such that f double prime of C equals negative 3 on 0, 1? All right. Pause the video and try that one. So we're given f prime. We need to find f double prime. So if we move down a level, we're using MVT or Rolle's. We can't use Rolle's because that only applies if the slope is 0. So we're going to use the conditions, check the conditions for a mean value theorem. It's continuous, it's smooth, so that means we can check the slope of the secant line. And we're going to say that there must be a C such that f double prime of C is equal to f prime of 1 minus f prime of 0 over 1 minus 0. So we use the y values that are given to find the slope of the secant line. F prime of 1 is negative 1. F prime of 0 is 2. So we have negative 1 minus 2. 1 minus 0 is 1. And we get negative 3 over 1. And that's what the question was. So we say, I guess we should say this. Before this statement, we can say there is C on 0, 1 such that f double prime of C is equal to negative 3 by the mean value theorem. Okay, and we'll stop there.